All right, as we study systems of equations, we've discovered that we can solve equations through graphing, right? So if we have two lines that intersect, the point of their intersection is the solution. We have also discovered that if we graph and they have the same slope and different y-intercepts, then they will never intersect, so they have no solutions. Or if we graph a line and then we go to graph another line and lo and behold it's the same thing, identical lines, that's supposed to be on top of each other, then we know that that it has infinitely many solutions to that system of equations. Okay, there's also another method for solving, because if we had, say a y-intercept of 1,000 or something, that's really an absurd graph to go up and find 1,000 and then do its slope and everything like that, right? So we want to have another method for solving equations, systems of equations, besides just graphing. So we did do substitution, and that's a super useful thing. We wanted to get one of the equations set equal to x equals the stuff or y equals the stuff, and then we substituted in to the other equation, that expression that we found, so that we're down to one variable. Super useful. There is kind of a fast way to do some of these, and that's what we're going to talk today about, is solving by elimination. So before we get there, I just want to confirm with you that 3 plus 2 does equal 5, right? And it's also true that 8 plus 4 equals 12. And if I add these two equations together, 3 plus 8 is 11, 2 plus 4 is 6, 5 plus 12 is 17. This final equation is also true, isn't it? That 11 plus 6 equals 17. It's also true that if I were to take that first equation, 3 plus 2 equals 5, and multiply every single term by -1, I still have a true equation. Right? So there's a lot of really cool things we can do with equations, and we're going to use some of those characteristics to solve here. So with this set, number 1, if I were to add these two equations together, something really great happens. 3x plus 3x is 6x. 4y minus 4y, well that's 0, equals -5 plus 11, that's 6. Notice that already I have gotten rid of the y variable. So now it's easy for me to solve for x. I can just divide both sides by 6, and now I know that x equals 1. That was quick. If we were doing this graphing, I would need to solve both equations for y, then find the slope and the y-intercept, right? All of those things. In this case, then graph them and find where they intersect. If I were solving using substitution, I would need to set one of these equations y equals stuff or x equals stuff, but here we just add it and we're ready to go, right? It's pretty slick. It's not always this fast, but that was a good starting point, right? What we're going to do now is figure out what y is. So unfortunately here we don't have a fast method besides just substitution. So I'm going to plug in either to this equation or this one. It doesn't matter. Either way, you'll get the same answer if you do the math correctly. So I'll use the top one. 3 times 1 plus 4y equals -5. Since 3 times 1 is 3, then we have 3 plus 4y equals -5. If I subtract 3 from both sides, that becomes 0. So I have 4y equals -8. Divide both sides by 4, and now we know that y equals -2. So my system of equations has the solution of 1 comma -2. If I were to replace the x with 1 and the y with -2, it would make both of these statements true. So let's check that out real quick. Whoops, I meant to erase. Let's see what we got. Okay, so if I did 3 times 1, that's 3. 4 times -2, that's -8. 3 minus 8 is -5, yes. 3 times 1 is 3. -4 times -2 is 8. 3 plus 8 is 11, yes. It solved both systems just like that. I recommend that you pause the video and try out number 3 on your own. See if you can solve this one. Okay, so if you have already tried it, then let's look at this together. I'm going to add the equations. 3x plus -3x, that's 0. 6y minus 1y is 5y. -18 plus 3 is -15. The x's are gone. I'm going to divide both sides by 5, and now I have the solution for y. Y equals -3. At this point, I can plug this into either of the equations, replace the y with -3, and see what answer I get. I'll use the second equation, but once again, either one is fine. Minus -3 is, minus negative is the same as +3. So we have -3x plus 3 equals 3. So I'll subtract 3 from both sides. Now we get -3x equals 0. Divide both sides by -3, and we get that x equals 0. So there's our solution, 0, -3. So the elimination part gets us to an answer quite quickly, and then we have to substitute to find the other term. Okay. Now, if I were to take this problem 5 and add all of the like terms, I would get -10x plus 6y equals -30. And unfortunately, in that scenario, none of the variables goes away. I would still have an x, I would still have a y, and a constant. So it wouldn't help me to add these together as they are. However, because I have a -5x and -5x, right, they have the same coefficient. What if I were to change the sign on one of them? If one could be positive, then when I add them together, it would be 0, right? So what I'm going to do is multiply the top equation, the entire equation, by -1. Okay, and I'll write what I get down here. So -1 times -5x is 5x. -1 times 2y is -2y. And -1 times -15 is +15. Okay, so now I can add these two equations together, and the x's will go away, which was what we wanted. So one little step and I got there. -5x plus 5x, that's 0. 4y minus 2y is 2y. -15 plus 15 is 0. Divide by 2, and we have that y equals 0. To find x, let's just go ahead and substitute. I'll use the lower equation this time. -5x plus 4 times 0 equals -15. 4 times 0 is 0. So we have -5x equals -15. I could divide both sides by -5, and I would find that x equals 3. So the solution to this set of equations is 3, 0. We could have, incidentally, even plugged in y equals 0 to that equation and solved, and we would have gotten the same answer for x. So any of the equations that we create, you can use those to substitute back into and find out what we get. All right. Pause the video. Let's see. I want you to see if you can do number 6 on your own. So take an attempt at that. Because we have 6x and 6x, they're both positive. If I were to divide stuff away, add the two equations together, sorry about that, neither the x's nor the y's would go away. So I need to make a slight change so that they will. I'm going to multiply this lower equation by -1, the whole thing. So I'll get -6x minus 2y equals 12, right? We multiply all the parts of it. Now I'm going to add these two equations together. 6x minus 6x, that's 0. 6y minus 2y, that's 4y. 12 plus 12 is 24. Divide both sides by 4, and we get that y equals 6. All right, now we can plug that into any of these three equations, right? We've got 1, 2, 3. We can plug it into any of those. Let's choose the new one that we just made. I'm going to replace this y with 6. So it'll look like -6x minus 2 parentheses 6 equals 12. Let's start with this multiplication problem. -2 times 6, that's -12. So we have -6x minus 12 equals 12. If I add 12 to both sides, I will get, -6x equals 24. Dividing both sides by -6, I will get that x equals -4. So there's our solution, -4, 6. I'm just going to check real quick and make sure that that works. Negative 24 plus 36. Negative 24 plus 12. Looks good. I think we've got our answer there. Okay, so just to recap so far, sometimes we can add two equations together and a variable goes away. Sometimes it takes a little step of multiplying one of the equations by -1 and then it goes away. Sometimes it takes a little bit more than that. So let's take a look at 7. If I were to add these together right now, would we get 0x or 0y? No, right? We'd get 3x and 5y. If I were to multiply one of the equations by -1 and then add the equations together, would I get 0x or 0y? And the answer again is no. So let's look at each set of the variables. Looking here and here, I have 4x and -1x. If I were to multiply one of the equations by something so that when I add them, I will get 0x, what do you think would be a good idea here? What if we were to multiply this equation by 4, is that what you were saying, and then get -4x, right? So we have 4x minus 4x, that would be 0, right? So that is a viable option, that's good. I just want to show you that we have more than one. Suppose I'm looking at the y's. What could I multiply one of the equations by so that when I add the equations, I get 0y? What if we multiply the top one by -4? Right? Then we'd have -4y, add it to the 4y, and we'd get 0 y's. So two good options. You just pick one of them and then move forward with it. So I'm going to multiply this lower one by 4. We'll get -4x plus 16y equals 28. Notice how I multiplied every single term in the equation. I'm going to scribble this out just so that I know I'm adding this top one and this one that I just drew. So when I add those together, I get 0x plus 17y equals -11 plus 28. That's also 17. If I divide both sides by 17, I discover that this equals y equals 1. Okay, to get my other number, I'm going to plug that into one of the equations. So 4x plus, instead of y, I'll put 1 equals -11. To isolate x, I'm going to subtract 1 first. Get 4x equals -12. Then divide both sides by 4, and we get that x equals -3. So the solution here is -3, 1. Okay, where do we want to go next? Let's take a look at this one here, 8. I'm going to create a little bit of space here. So there are a couple of options here. If I added, I would still have x's and y's. If I multiply by -1, I still would. But let's look at these x's. Is there something I could multiply one of the equations by so that when I add them together, I get 0x? We have -8 on top, -8x. What if the bottom one could be 8x? Right, and then when we multiply, we'd get, or when we add them together, we'd get 0. So what do I need to multiply that equation by? Is 2, right? Multiply this bottom one by 2. So that's a possibility. Let's talk about the y's. We have -2 and -5, so I need to multiply one of them by negative something so that I have a positive and a negative. But does -2 times something equal -5? Yes, but it's a decimal, not super clean. So what you could do is multiply both equations, right? We could multiply the top one by like 5, and then if I did, I'd get -10y. So what would I multiply this equation by so that I'd get +10y? -2, right? So I could solve it by multiplying both equations. Because there was a one-step solution or method to get there, that's the one I want to choose. So I'm just going to multiply this by 2, then we'll get 8x minus 10y equals -30. Cross that out. We're going to add the top and the bottom equations. -8x plus 8x is 0. Negative 2y minus 10y is negative 12y. And negative 6 minus 30 is negative 36. Divide by negative 12, and we get that y equals 3. Plug it into any of the equations up here, right? We have 1, 2, 3 choices. Maybe I'll do this bottom one. 8x minus 10 times 3 equals negative 30. Multiply here, we get negative 30. So 8x minus 30 equals negative 30. If I add 30, get 8x equals 0. Divide by 8. I think x is going to be 0 in this case. So we get 0, comma, just positive 3, excuse me. Let's see, that would be 0 minus 6, 0 minus 15, 0 minus 30. Looks good. I think all of these would work. I think you could do number 9 on your own. There's 2 really good choices here for stuff to multiply by. Right? It might be worth, even if you don't solve it all the way to the end, it might be worth thinking about what are the choices. To get rid of the x's, you could multiply the top equation by 2, right? Then you'd have 2x minus 2x. If you were getting rid of the y's, you could multiply the top equation by 3. And then you'd have like 3x plus 6y equals negative 9. But when you add them, the y's would go away, right? So that's a good one. You could keep going there. Let's look at 11. Okay. On this equation, negative 2 and 3. This is one of those where we don't really have a slick, easy way to go about this. So if I wanted to eliminate the x's, I think what I would do is find the least common multiple of 2 and 3. So if I list all the multiples of 2, or maybe just a handful, and I list a bunch of multiples of 3, looking for the smallest number that they share, that's 6. So I could multiply stuff to get 6's, right? So I could say, okay, I'm going to multiply this by 3, multiply this by 2. They do have opposite signs already, right? That one's a negative. So then if I add, I would get rid of that. So that'd be good. It's a good choice. There's also, if we're looking at the y's, we could think of the least common multiple of y. So let's start with the largest number. 5, 10, 15 are some multiples of 5. So let's see, 10. 10 is also a multiple of 2, right? So we would want to make both of them equal 10 in there. So I could multiply this top equation by 2, and then I'd get 10y. And multiply this one by 5, and I'd get negative 10y. So again, we got 2 great choices. It's just a matter of choosing the one that you want. Since this is written, let's just go ahead and pursue this. So we'd have 2 times negative 2x is negative 4x. 2 times 5y is 10y. 2 times negative 10 is negative 20. Then for the second equation, we'll choose a different color. 5 times that thing, we'd get 15x minus 10y equals, let's see, 15 and 20, 75. Okay, notice that the y's will go away. Let's pick another color. So negative 4 plus 15, that's 11x equals 55. Divide by 11, and we get that x equals 5. Now, even if we had solved to eliminate the x's, we should, at the end of the problem, still get that the answer is x equals 5. We would have found y first, but then eventually we would have discovered that x equals 5. Okay, so now I have 4 equations I can plug it into, right? Lots of choices. So let's just do, the second one. Like 3 times 5 minus 2y equals 15. 15 minus 2y equals 15. Negative 2y equals 0. Y equals 0. think in either case, you would want to multiply this top equation by 5. And then depending on whether you want to get rid of the x's or the y's, that would help you decide what to multiply the lower one by, either 6 or 2, right? I'd probably do 2, then you get a little bit smaller numbers. But you could go ahead and solve that one as well and see what you get. If you ever get to a place where the numbers go away, the variables go away, and you get number equals number, that either means infinitely many solutions or no real solution. It depends on if this is a true statement or if it's false. So if you get 3 equals 3, that's true. That would be infinitely many. If you get something like 3 equals 5, that's false. You would have no solution. Sorry, it's like a 0 with a line through it. No solution. Okay, so we didn't have any of those on this notes page, but you may have some of those on the assignment. Okay, good luck.